Good afternoon, everybody. Welcome to our next session at PyCon 2017. Two brief announcements before we start. Firstly, if you have any electronic devices that are liable to make noise, please make sure that they don't, because if they do, everyone's going to stare at you and you're going to feel bad. Secondly, there is a 10-minute gap between presentations. This is to allow people to get from one room to another, so please don't feel that you need to leave this session before the end in order to get to your next one. With those out of the way, I would like to welcome Jonas Neubert, who will be talking about factory automation with Python. Make him feel welcome, please.
Let's talk about factory automation. This is my title slide, obviously. And I did some keyword stuffing there. And I put this nice stock photo of a car assembly line into the background just to make it extra clear that this talk is about factory as in building a group of buildings where goods are manufactured or assembled chiefly by machines. That's from the Oxford English Dictionary. This talk is not about an interface for creating families of related or dependent objects without specifying their concrete classes, which is the design pattern that we all know. Maybe a couple of people leaving in the back there, that's okay. This is also an example of how the field of software development sometimes borrows or maybe steals terminology from other fields of engineering. Funny story, I got my job title stolen this way. I write software for factories, and a couple of years ago I could say, hey, I'm an automation engineer, people would understand what I'm doing. Then a DevOps crowd came along, kind of claimed that word for themselves. In fact, I think that this lack of clear terminology and job titles is one of the reasons that industrial automation is not as prominent on people's minds when they think about where they can apply their software development skills as like the hot topics like web development and data science. So this is what this talk is about. It's going to be a very basic introduction to the fact that you can use your Python skills in factories. So a couple of words about me. I'm a software engineer at Tempo Automation. We have a circuit board factory in the middle of San Francisco, and we use automation there to automate the setup process of the factory so that we can send you your prototype or small batch circuit boards really fast. But I've been causing downtime in other factories for many years. I'm on the internet. If you're sitting all the way in the back, you want to follow along with the slides, this is the link. If you have trouble spelling my name, don't worry, I sometimes do too. You can go to my Twitter and I just send out a link to these slides. So about this talk, this is my first time at PyCon, and the organizers, thanks. And the organizers had a couple pieces of advice from me as a first timer. One of them was, don't do an on-stage live demo. And I was like, okay. So this thing on the screen is also right here. And this is going to be the PyCon 2017 chewing gum sorting factory. And we'll be using this and running this live. In fact, there's a webcam here that's going to like live stream onto the screens what's going on for the demo later. So everyone cross your fingers because this joke might be on me. So this is what it is, top view. What I brought is a conveyor belt, so it goes back and forth. There's a barcode reader here, the little black square with the red and white writing on it, scans barcodes. There are some little pusher paddles, like on a flipper machine. They go like this, and the other one, obviously. So, and we'll be using those. That's really all you need for an automation demo. Every automation demo needs sensing. So I brought you what I think is the most common sensor in any factory or automated setting these days, the barcode scanner. Next to its siblings, like the temperature sensor, pressure sensor, these kind of things. Barcode scanner is what we're using today. Actuation is the second thing you need for an automation demo. I wish I could have brought a robot arm, but they don't travel so well in suitcases. So the conveyor is what you get. And brains. We're just going to skim over that at the very end because we're all software developers. We all know how to implement business logic. And this is really an automation demo. If anyone ever wants to sell you an automation demo that's missing one of those pieces, return it. It's a scam. Everyone's waiting for the first line of Python on the screen, I think. So let's dive right in. This is a barcode. This is the barcode scanner. That's the one I brought today. The left side, that's where the photons come shooting out. That's the laser that's reading the barcode. On the right side, that's where the electrons are coming out. That's the data that we're interested in. We want to know, hey, barcode scanner, what did you read? And it's using this protocol called RS-232. Some people in this room might be too young to remember computers having serial ports. RS-232 is what specifies the type of cable, how long, how many strands, all that kind of stuff. Also the type of data going through it. The good news is Python is old enough to remember the serial port. So there's a library to talk to the serial port in Python. So this is when I flip over. That totally worked. So what we have here is a terminal at the top. I think you've seen that sort of thing before. And then this camera here. So we're looking right over the shoulder of the barcode scanner. This is it. Let's try to ask it for a barcode. So I'm just going to pip install PySerial, which is the library. Obviously, I'm prepared. I had it installed. Right? So we import serial, and then we open a port. If you have never opened a serial port, this is what it looks like. So on Windows, this would be like COM1, COM2, COM3. I use a USB to serial adapter. That's why it's that long name. It wants to know a couple of things. The baud rate is how fast it is. Parity is like how the bits are positioned relative to each other, kind of. Byte size is something I think it wants to know from us. How do I know what it wants? Well, I read the... Sorry, what's that? Oh, I got a typo on byte size. Oh, thanks. That would have been a disaster. And I'm going to ask for a timeout that's pretty long because this is a demo. Let's see. OK, so looks like we opened that port. Now we have to tell the barcode scanner something. So it's going to be in bytes. Strings are for humans. Bytes are for machines. Easy. So we're just going to send it that character. Did you see the laser come up on the thing? It did some reading. Now we have to ask it, hey, barcode scanner, what did you read? Read line. Boom. That's a barcode. Let's try another one. Same thing again. We read. This time, let's strip off that white space. Maybe decode that to turn it into a string for humans. That's right. If you don't believe me, they actually print the number right next to the barcode. So it is right. OK. So we're software developers. We like to abstract things, make them more modular, reusable. So I wrote a class that does the same thing. Just open the port. I'm doing it a little abbreviated on that slide because I don't have enough space on the slide here. Reading barcode, just what we just did. We sent the trigger. We read the line. We clean it up. We return it. With these things, when you write instrument drivers, here's a trick. Make them context managers, because that way, if your code that does something with a barcode it just read has an exception, cleans up after itself, closes that port. Especially on Windows, it can be a bit of a pain having a program hugging that port that's crashed. So let's just try if this works. I'm just going to copy that right over here, paste it in. I'm going to call this the MS3. That's the name of the instrument that I'm using. Barcode reader driver. Got to give it that annoying name again. And then we just do read barcode. Oh, there's no barcode there. I wonder what it's going to do now. Oh, no read. OK. There we go. So that's cool. Instrument driver, 15 lines of Python. We are automation engineers now. Couple of caveats. Serial cables are only up to 15 meters long. If you have a big factory, you don't want to have your server that's running the business logic right in the middle there. You want it off to the side, maybe somewhere else in the world. Also, you'll be using lots of these things because this is a toy factory, like toy as in toy example. A real toy factory will have hundreds of barcode readers. You won't find a server to plug them all in. So it would sure be nice if we could read that barcode over the network. And And you know how Python gets advertised as like comes with batteries included? Well, this is one of the best batteries in Python, I think. It comes with this cool library XML-RPC that's in the standard library XML. You guys know what that is? RPC, remote procedure call. And what it does is it wraps our class that we just wrote, barcode reader driver, in a little bit of setup code, and runs it as a server on the network. I'm going to show you how that works. Paste that in again. It's not returning because we told it to serve forever, so it's stuck in a loop. Let's open up a new shell. IPython from XML RPC. This time we want the client. Import server proxy. So it's going to be on localhost, obviously. Anyone remember the port we use? 2121, that's right. One person still paying attention. Read barcode. Read barcode was a function on the class we wrote. And over the network. So now we could have done this. We could have done this from anywhere in the world, read this barcode. That's pretty cool. So let's just recap what we achieved so far. So first of all, I hope I managed to communicate that there is such a thing as industrial automation equipment. We saw that Python works fine for interfacing with it. In fact, pure Python. We used PySerial. It's a Python-only library, no C extensions or anything in there. And our code was like 15 lines. In fact, Python's batteries are really useful for industrial automation, even though they were probably not written with industrial automation in mind. And I would actually argue that the results that we can achieve with these tools are often more elegant and efficient than what's documented or recommended by the vendors. Because it turns out for this barcode scanner, that's more than 20 lines of code that we just wrote. Cool. So we've got sensing covered. We talked to a barcode reader. In fact, I'm skipping some slides here. So we're going to go back and just get this ready. What I was going to say in those slides is that it does make sense when you work with a device to maybe publish the package on PyPy, which is what I did. It's called Microscan, like the company that makes these things. And I'm going to use maybe exit out of here first. I'm just going to use what I wrote in that library. There's no rocket science in there. It just deals with like misreads and things like that better. So I want to use that for the demo we've got coming up later. But back to the presentation. Sorry for the intermission. Let's move on to actuation. So what I brought is this conveyor belt. And this is kind of the documentation you get with it. It's like this box with all the cables. This is kind of the API docs of that thing. Just in case it's not clear, that's a black cable, white cable. These are physical cables, and they want voltages, 0 to 5 volts to control the speed of the conveyor. Nobody wrote a Python library for that sort of stuff because your computer can output those. So I'm actually going to use this slide to introduce you to the most important cast member of every factory out there, the Programmable Logic Controller. I don't know, it's called PLC. Maybe you've heard about it. Not. This is what I look like. If you work in a real factory, your controls engineer will tell you what's running in the factory, what it's doing, what variables are in and all that. If you just build a little demo setup for PyCon, you are your own controls engineer. You go to eBay, because eBay is where factories, like when a factory dies, the PLCs go to eBay. And that's where you get it. What is in there? To the left side, the thing with the heatsink, that's an industrial PC. Industrial means it's very rugged and low-powered, usually. And it's running a simple OS. Depending on the vendor, it might be a proprietary one. This one's running Windows CE. The magic thing in there is a real-time kernel that's running a little piece of software at guaranteed time intervals over and over and over again. And you program it in a family of languages called IEC 61131, which is pretty ancient and kind of funny. On the left side, on the right side, we've got these I/O slices. You buy those. This is the 5-volt one for the speed output. This is the one for the digital one. You just like kind of slide them into each other, slide them into your PLC and you've got a configured PLC, you can mix and match them. This is what the code looks like. This is a language called structured text. Don't worry understanding all the details. The interesting bit is these variables up here, those are bound to an actual physical output, voltage that's getting switched. And even better, these ones are writable over the Ethernet. So that's what we are after. Every PLC vendor has a different protocol. All the ones I looked up, like Siemens and the like, there are packages available for Python. Same for this one. The vendor uses a protocol called ADS to make these variables accessible over the network. Multiple options out there. There's one on PyPy that's called PyADS. That's wrapping a C library. I'm kind of a fan of pure Python because it's more portable. So Chris Wiedemann is published one called also PyADS, kind of name clash there. And then my former colleagues at Council, I put some pressure on them because PyCon's coming up. They just open sourced the fork of that, which is captures more variable types and things. So we'll be using this Council PyADS library in this demo. So let's see what we can do with that. There's a lot of boilerplate to set up the connection, similar to serial, to the serial port. Here there's a security layer, because if anyone can write those variables over the network, like maybe your uranium centrifuges suddenly start running too fast or things like that. We don't want that. So what we're going to do is we copy that. So this is basically going to set up the connection and set this conveyor on variable to true, which should switch the conveyor on. Paste that in. Just one little thing I'm doing here. I'm going to switch the camera over so that you all can see the entire thing. Let's see. You hug that. Here we go. A ducky sitting on the conveyor belt. Let's switch this on. Oh, it's moving. Now it's up to me to save ducky. You'll see. I'm telling you, typing on this podium is hard. Let's put ducky back on there. A couple of other variables we can write. Let's say we want to reverse it. I want to reverse it. I want to go the other way. True. There's one called speed. That's an integer. And it's between 0 and 100. And I like 100. Okay. Everyone say goodbye to ducky. Oh, no, it's not. Thank you. I actually brought another ducky. Okay, so you might be asking, like, so there's Python, there's code running on this PLC, what's going on? Rule of thumb, and your controls engineer might argue with you on this, but really anything that touches voltage outputs and signals directly runs on the PLC. Anything that's related to human safety, machine safety, or is otherwise timing critical, run on a PLC. Like in my case here, you might have seen that note in the conveyor belt documentation, don't switch the reverse and the on input at the very same time. That's implemented in the PLC, that's machine safety. Anything that connects to outside services, your ERP or database or anything like that, or that provides a user interface, is probably a better fit for Python. And one of the reasons is deploying code to this PLC almost certainly requires factory downtime, might need recertification, extensive testing, whereas your Python code is probably on a much faster deploy schedule. So you want to align the purpose of what you're writing with the kind of deploy schedule and procedures you have built around it. Generally, you shoot for your usual daily or continuous deploy of your Python code, and just a don't touch this approach to PLCs. Cool. So we covered sensing actuation, brains. I'm just going to tell you right now, I brought this little Python package, I call it GUM. It's got a database with 8 lines of barcodes for all these different chewing gum colors. Pass it a barcode. it tells you what the color is. And this is the business logic of the PyCon 2017 chewing gum sorting factory. So basically, we start the conveyor, we read the barcode. If we don't get one, we try again. Once we have a barcode, we find out the color from our proprietary chewing gum database. If it's more red than blue, we flip the right pedal. If it's more blue than red, we flip the left pedal. This is what that looks in Python. In the interest of time, I'm not going to copy it this time. Instead, I'm going to go right over here. You know what's ironic? When in a talk about automation, the autofocus is switched off. There you go, better picture. Okay, so let's see. I'm going to exit out of here. We already got that XML RPC server running that's telling us the barcodes, and we're talking to the PLC over the network, so there's no direct to machine communication going on from our central server. It's all happening over the network. So we got the barcode, it scanned it, and it's sorting it to the right side. Guess who forgot to put the little trays here that catch the chewing gum? See, that's perfect setup. Let's just run a couple more down. This is pink coming. Pink is more red than blue. This is kind of orange. Yeah, more red than blue. Another different kind of orange. Just FYI, Trident is the only brand that prints the barcode on the short side of the package. So I don't even chew gum. Yeah, so this is the factory. Total. Total lines of code, of Python code running here, really less than 100. And we did something kind of meaningful. Well, kind of meaningful, right? We've got 3 instruments using 2 Ethernet connections. Obviously, your real factory is going to be having more instruments, more diverse, and just more in sheer quantity. So it's going to look more like this. And the first thing that your factory manager will ask you is for HMIs, human-machine interfaces. They want to find out what these variables are that are in the PLC, maybe click a button, trigger a barcode scan. So you're going to put a little web app in front. You dig through your Python tool chest, maybe Flask, Django, something like this. And sure, there'll be more. And they'll also be talking to all the other data sources in your business, maybe comparing barcodes to chewing gum color library. Then you'll run into this interesting dichotomy. People are interested in state. They want a quick response from the web server and want to know the current state. Is it running? Is it not running? Machines, things take time. If your shaker process has to shake a minute, well, the response time is a minute, and you're not going to make it faster. Also, they're inherently singleton. Like a web API, you send a ton of requests to it, they just spin up more AWS instances. That's not how it works for 6-axis robot arms. A really good tool to actually bridge that gap is using task runners like Celery in the background that keep your instruments running while the front end can query them for what the state is. So they're like the virtual representation of your device. Then you automated everything. There's buttons to trigger all the actions. Your operators are going around clicking the same button every day. Someone's going to be like, can't we automate that too? And you'll be putting in like a factory level scheduler that's clicking the buttons for people. So you put in an API, some Django REST framework maybe, something like that exposes all those button clicks that operators were doing as an API, and you have a process scheduling server that's going around making sure the chewing gum packages arrive at the barcode scanner in the right time, say. And then your operators come in the morning and they're like, what's going on? All the chewing gums all over the floor. We need metrics and logs of what happened. So you put in logs and stuff, and soon enough, this is looking like your standard service-oriented architecture, microservices. And you'll probably be using just the standard tools of modern software engineering. You'll be putting in a message queue maybe, so you can go out there and All the big ones that have Python libraries available, like ZeroMQ, Kafka, are probably a good fit for what you're trying to achieve here. So this is what could be coming after you've done your little modest barcode scanner with one conveyor belt. I hope this was a good intro to just give you a taste of how this works. How do you talk to machines? How do you make factories run? I think industrial automation is a really cool domain for software engineers. If you show up as a newbie in data science, it might look like everything's been done. Industrial automation, because it's a bit of a niche, it's not like that at all. It's a wide open field. Here are a couple of things you could just start doing and do something useful. You could write device drivers. They're basically the APIs for robots. The way I see it is every time you publish a device driver as open source, you make that device available to academics, hobbyists, tinkerers, who don't have the luxury of a field application engineer from the manufacturer who can tell them how to set it up for them. If you're not into tinkering with tangible things, that's okay. File formats and protocols. There are hundreds of them. Every machine has its own proprietary protocol. And people on the factory floor, and many factories, spend a lot of time just converting between one format to another using tools like Excel. By writing viewers, converters, parsers, there's just a huge scope of things that can be done out there. If you're into data science, sorry data scientists, I kind of used you as the example for the overcrowded, too popular field. If you're into that, actually, this is also exploding in factories right now. This concept of predictive maintenance, where you monitor the vibration of a motor over time and then predict when it will fail so that you can monitor it, is huge. If you want to Google it, Industrial Internet of Things is the buzzword. And same for scheduling. Factories are super complicated networks of goods and data. Making them all show up in the right place at the right time is a huge scheduling problem. Same thing, lots of work to be done there. On security, I'm just going to say, you'll be busy. And with that, I am on my last slide. And I think this went surprisingly fast, so we probably have time for a question.
Thank you, Jonas. I think we have time for one, maybe two questions. If anyone has a question, please go up to one of the microphones in the aisle.
Yeah, great presentation. For the device drivers, do you have any tips on writing those entirely in Python, or do you use some C libraries, or are there any standards for best known methods for creating those drivers?
Well, many questions in there. The answer is no. So basically, for every device and for every application, you really have to judge what's the right thing to do. In some cases, it is cut the cable, send the voltages that it wants, and you're good. Sometimes there is a pretty good, let's say, Windows software, and they even the vendor gives you a COM object or a DLL or ActiveX object, something like that, and maybe then you just want to wrap that. It really depends. It also obviously depends on encryption and things like that. Some vendors encrypt the communication. So long story short, it really depends on a specific device. I always, and you kind of heard that during this presentation, try to shoot for pure Python and sending bits and bytes over Ethernet or serial ports.
Hello, great talk. Thank you very much. I have a quick question about these serial ports. In practice, you would having a serial server that converts all the serial inputs into a network right away. Is that how it's done?
Well, I actually skimmed over the part where most factories usually have these serial to Ethernet converters scattered around, and that's true. You would obviously be using that, even though sometimes those can be hard to communicate with. Devil's in the detail there. One place I worked at, actually the folks at Council who contributed that PyADS library, our approach there was to use XML-RPC servers just as this boundary, one team works up to the XML-RPC server and then other teams have a unified interface to every device, and that's how we did it there. But it's, again, there are like hundreds of manufacturers with like thousands of devices, so it really depends on the case.
Thank you.
Thank you very much. That's all we have time for. Thank you. Please thank Jonas once again. Thanks.